Question 8 is a straight line graph question. I know it's a straight line graph because it's got y equals 4x minus 2, and that's a linear equation, so I know it's going to be a straight line because it's linear. On the grid, draw the graph of y equals 4x minus 2 for values of x from x is minus 2 to x equals 3. So the fact that they want you, and they've specified what values they want you to do, means that you need to put a table of values in for this with your x values and your y values. So we want the x values from -2, -1, 0, 1, 2, 3, because it goes from -2 to 3. And in order to find y, I use the equation y equals 4x minus 2. So I'm going to start with the positive numbers because they're easier. So 4 times 0 is 0, take away 2 is -2. 4 times 1 is 4, take away 2 is 2. 4 times 2 is 8, take away 2 is 6. 4 times 3 is 12, take away 2 is 10. Now, if I'm not very good with positive and negative numbers and multiplying and things, then I'm going to go ahead and plot all those positive coordinates first and extend the straight line to help me. But I should know that 4 times -1 is -4, and -4 take away another 2 is going to leave you with -6. And also 4 times -2 is -8. Take off another 2 is going to leave you with -10. So there's my table of values. I just need to plot these now. So the first one is the coordinate point -2, -10. So along the corridor -2, down the stairs -10. Then I've got -1, -6. Then 0, -2. Then 1, +2. Then 2, +6. Then 3, +10. And then I'm going to use a ruler, join those up. And that's that question done for 3 marks. How are the marks distributed for this? You get 1 mark for at least 2 correct attempts to find points by substitution. So that's by getting 2 correct. You get another mark for plotting at least 2 of your points correctly and then joining them to make a straight line. And you get the 3rd accuracy mark for getting all the points between -2 and 3 plotted and drawn in. Question 9 is a plan and elevations question. The diagram shows the front elevation and the side elevation of a prism. Prism is a 3D shape that has a uniform cross section. So remember, it's a loaf of bread that's been sliced. It's got the same slices going all the way through. Front elevation means if you were looking at it exactly from the front end, and side elevation means you're looking at it exactly from the side end. So the side of this shape looks like that, and the very front of it looks like this. The fact it's got a line across the middle just means that something's happening on the shape. It doesn't mean that that's like one side and that's another side. It means that is what you see when you look at it head on. On the grid, draw a plan of this prism. Now, plan is when you are looking directly down on something, like a bird looking down on a worm or something. I probably could have thought of a much better way of saying that, but I mean, who doesn't like little birds, and birds eat worms? So draw the plan view of this prism. So imagine you're looking down on it. What are you actually seeing? Well, hopefully you'll be seeing a rectangle that has 1, 2, 3, 4, 5, 6 squares going across. And because that's the side it's going to be, 4 squares going back. So I'm hoping to see a 6x4 rectangle. 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4. So that's what you'd see if you were looking directly down on this shape. And that's a 2-mark question. You get 2 marks if you've got that right. Any 6x4 rectangle. You get 1 mark, so if you haven't got that right, but you've got one of the lengths correct, so either a side that is 6 or a side that is 4, then you would get 1 mark for that. Now in the space below, we need to draw a sketch of this prism, so that means they want the 3D shape, and it's a sketch, so it doesn't have to be to scale. Now it tells me there that the side is going to be that shape. Okay, because I know it's a prism, I know that that shape is going to be running all the way throughout it. So first thing I'm going to start with is that trapezium at the front. So just because it's a sketch doesn't mean I don't have to use a ruler. It's not what a sketch is. So that's going to be the cross section of my prism, and I know that it's going back like a prism, so I need to make all of these sides the same length and parallel, which I've just done a really poor job of actually because I didn't measure them. So that's going to be what your 3D shape actually looks like. And that's a 2-mark question. You get 1 mark for any 3D shape with a trapezium cross section, and you get the second mark if you've done it correct. Question 10 is angles in parallel lines with a little bit of geometry thrown in. So there's your set of parallel lines. You know they're the parallel ones because they've got the arrows on. So ABC is parallel to DEF. EBP is a straight line. AB is equal to EB. Angle PBC is 40. Angle AED is X. Work out the value of X. Give a reason for each stage of your working. Okay, so I need to find what that angle is, and the only one I know at the moment is that. Now, as soon as I look at this question, first thing I want to do is write in there that that's 40 degrees. And the reason I do that is because 2 lines are crossing and their angles are opposite each other. So I'm going to say, first of all, that angle ABE equals 40 degrees. And that is because they are vertically opposite. And vertically opposite angles are equal. So that's my first reason. Okay, now I know that's 40. I can see that this here is a triangle with 2 sides the same length. So that's an isosceles triangle. And the sides that are the same length are these 2, which means that these are the 2 base angles. So inside any triangle is 180 degrees. So if I do 180 degrees, take away that 40 degrees, it leaves me with 140 degrees that I need to split between these 2 angles. So 140 divided by 2 equals 70 degrees. So I can write there that that is 70 and that is 70. So I'm going to give my reason here. That is angle BAE. So BAE is equal to BEA. And they're both equal to 70. I've marked it on my diagram as well as written it down here, just in case I get my geometric notation wrong, in which case the examiner can still see exactly what I've done up here. So I've said they're equal to 70, and the reason is because base angles of isosceles triangle are equal. So the final stage left then in my working out is to find this angle here, and I need to know it because they all go together to make a straight line. Now, as this is one of my parallel lines and that is another of the parallel line, I can see that what I'm going to end up with here are 2 equal angles. So that one actually equals 40 degrees as well. You could also have said it's because it makes a Z with that angle. So I know that angle BEF is equal to 40 degrees. And the reason I chose is because it's corresponding with that angle there. So I'm going to write corresponding angles are equal. So once I know that that's 40, I can do my final stage of working out, which is that angle X is going to be 180 degrees, take away that 40 degrees, take away that 70 degrees, and 180, take away 40, take away 70 equals 70 degrees. And if you wanted a reason for that, it's because angles on a straight line sum to 180 degrees. Question 11 is negative and fractional indices. Find the value of 5 to the power of 0. That's 1. Anything to the power of 0 is 1. Find the value of 27 to the power of a third. In order to do this, you need to consider that whenever you have a fractional indice, whatever the bottom is, the denominator, that's going to end up being a root. Okay, so you're going to end up with the root of 27, and it's the cubed root because it's a 3 there. If it was a 2 there, then it would just be a square root, but it's not, it's a 3, so it's a cube root. So the cube root of 27, what times itself 3 times is going to give you 27? Well, 3 times 3 is 9, and 9 times 3 is 27, so the answer is 3. And part C wants you to find the value of 2 to the power, find the value of 2 to the power of negative 3. Well, we want to get rid of the negative first of all, because it's the reciprocal, so you put 1 over 2 to the power of 3. And 2 to the power of 3 means 2 times 2 times 2. So 2 2s are 4, 4 2s are 8. So you actually end up with 1 over 8. Question 12 is a circle theorem question. And this is one of those that we have to be really careful of, that we don't just assume the examiner has put all the information on the diagram that we need. So it says here, S and T, there's S and T, are points on the circumference of a circle with a centre O. PT and PS are tangents. The fact that they've mentioned tangents means you should be thinking of 90-degree angles, but we'll come to that in a second. Angle TPO, which they haven't drawn in, so I'm going to go ahead and draw that in. That means I need the line PO, because angle TPO is 24 degrees. And they want us to work out the size of angle SOT. That's that whole thing there. So they want us to find that. Now, as I said, the fact they've mentioned tangents and the fact that here we've got a line going from the centre to the edge of the circle, that's a radius, and that's also a radius. So the fact that the tangent meets the radius means these two angles are both 90 degrees. And whilst the question doesn't ask for you to give reasons, generally you do have to give them. So I'll give the reason that OTP is equal to angle OSP, and that's equal to 90 degrees because a tangent meets radius at 90 degrees. Okay, so I know those two are 90. Now I know this angle here is 24 degrees, and that is actually half of this whole angle, so that's also 24 degrees, which means that this whole angle TPS is 48 degrees. So if I know that TPS is 48 degrees, and I know that's 90, and I know that's 90, and this here is a four-sided shape in which all the angles add up to 360 degrees, I can find my missing angle by doing 360 degrees, take away that 90, take away that 90, take away that 48. That's going to leave me with 132 degrees, With regards to mark scheme for this question, you get 1 mark for showing the 90-degree angles, and that's the fact that you knew a tangent meter radius at 90 degrees. You get 1 mark for showing that subtraction from 360, and you get the final mark for having the correct answer. Question 13 is an area question, but it involves algebra. The method is still the same. Okay, they want you to find or to show the area of the shaded region. So you find the area of the whole thing, then you find the area of the non-shaded region, and then you take them away. Regardless of whether it's algebra or number, that's the process you need to be doing. So the diagram shows a triangle inside a rectangle. All measurements are given in centimetres. Show that, so they're not even asking you to work it out for yourself. They're giving you the answer and they're telling you to show that the total area in centimetres squared of the shaded region is 18x minus 30. So let's find the area of the whole thing first. So it's actually a rectangle. So area of a rectangle is base times height. So it's that times that, double brackets. So I've got x plus 6 in one bracket times by 3x minus 5 in the other. So I'm going to expand these out. That gives me 3x squared minus 5x plus 18x minus 30. By the time I've gathered and collected all my like terms, I end up with 3x squared. Negative 5x plus 18x leaves me with positive 13x. Take away the 30. So that's the area of the rectangle. Now what I'm going to do is find the area of the triangle. And I can either half my base and then times it by my height, or I can do base times height then half it. I'll do base times height then half it. So 2x is my base, open bracket, because it's times by 3x minus 5. So 2x times by 3x is 6x squared. 2x times by negative 5 is negative 10x. And I need to find half of that. So half of 6x squared is 3x squared. Half of negative 10x is negative 5x. So that's the area of my triangle. That's the area of my rectangle. Now I need to do that, take away that. So it's going to be 3x squared plus 13x minus 30. Take away, and I can't just write this out as one expression because I'm taking away the whole thing. So I'm going to need to put that into a bracket to make sure it doesn't become separated. So I'm taking away 3x squared negative 5x. Now the fact that you've put it in a bracket means that you should hopefully not fall into the trap of subtracting that 5x. Because yes, it's going to be negative 3x squared, but here you end up with a takeaway negative 5x. So they're going to go together to give you a plus. Right, so you're going to have to add the 5x on. So what you end up with is a negative 3x squared, which will cancel that out. And then you'll end up with a positive 5x. And there's no numbers, so I can ignore that. So 13x plus 5x is 18x. And there's that negative 30 that I ignored. So I've considered the subtraction sign. I've dealt with the 3x squared, and I've managed to negotiate my way around that negative 5x. So that's then left me with 18x minus 30, and that's what the question was asking. With regards to mark scheme for this, there's a lot of different ways of getting it again. But if you followed my method, then you get 1 mark for using the lengths that you're given to find an area. So you get 1 mark for finding the area of one of the shapes. You get another mark then for showing that you've taken that area and subtracted that area. So that would be that mark there. You get a 3rd mark for managing to show that you were halving the triangle. And then you get the final communication mark for working with all the values correctly and getting the final answer.